Hi, welcome to another lesson in this module. This time we are going to see data architectures. So before I go deeper into the technical details, it's very important for me to mention that you should remain pragmatic in your choices. You shouldn't choose an architecture because there is a lot of sayings in the social media or because there is a lot of saying in discourse. You should always try to adapt them to your final business needs. So to stay pragmatic and also remember that there is no perfect solution, one size fits all solution. There is always these trade-offs you have to make. And finally, also remember to think long term, so about possible consequences of your choices, either on scaling or maybe on the extensibility of your whole platform. But anyway, let me go deeper into the technical details. The first architecture, the historical one that I mentioned in the short history of data engineering, is Lambda architecture. So in Lambda architecture, we have three main components. The first component is called batch layer, and it contains the immutable data that is processed in batch. And this batch layer generates some views in the serving part. The speed layer is the layer covering streaming and real-time processing that also generates some views in the serving layer, and both data views, are later exposed via a common query layer. Why this dissociation? So the dissociation is here because streaming processing always have some issues, like for example late data, like maybe some operations that cannot be easily expressed and cannot be exact. And on the contrary, these operations are much more doable in the batch layer, in batch processing, and that's why we accept having some maybe data of less quality from the speed layer that once every hour, once on a regular schedule, will be fixed in the batch layer. So as an example of such a conception, such a pipeline, you can see you can see it just here. We have our batch and speed layer, and we are generating some data. So let's suppose that we are at 10 p.m., 10 for example, and batch layer was so far responsible for generating the outcome before that time. On the other hand, speed layer is responsible for generating data for the current hour, and you see it very clearly, I think, right now. Whenever we will reach 11 p.m., batch layer will be in charge of processing data for the 10 p.m., ingesting it to its serving layer, but before that, the speed layer will need to invalidate the approximate data it has generated so far for 10 p.m. so that we always retrieve only 1 hour in the output in the query layer for the given hour. So it's exactly, you can see this picture exactly like in this. So we can see what I have this presented before in this picture. Even though this Lambda architecture looks controversial because of these many layers, it was a real-time data enabler, so at the time it was proposed. Before that, we have been thinking mostly in terms of batch, and it was very hard to start working on streaming processing because of all these data quality issues of streaming processing. And here it was a kind of nice trade-off, or having real-time data, albeit at lower quality, but that will be fixed in later by batch processing. Additionally, two layers, the batch and speed, could be scaled independently. They could also use different technologies, which from one side is good, but you will see in cons that is not that good as it looks like. And finally, thanks to this batch immutable data set, you had the possibility to reprocess data very easily. And among the cons, of course, there is this complexity of having 3 different layers to manage. Debugging, when data is wrong, you have to figure out from when it comes and when it happened. And also cost, because you have different layers to manage. You have the cost of the infrastructure, but you also have the human cost for the solution, because maybe in all these 2 speed and batch layers, you will have different technologies. So there is already a skills gap you might need to fill up before adding some new features. And Kappa architecture was an alternative to all these issues, because as you can see, it doesn't have this batch layer. It considers streaming data as a first-class data citizen. There is speed layer and data processing on top of it, with generating data directly to the serving layer, and optionally with the synchronization between this data in motion and data at rest storage in so-called master dataset. And what to do, for example, for reprocessing. For reprocessing, Kappa architecture recommends to add another job and reprocess the data from the last valid point. However, in practice, it looks a bit different. So that's just the theory. Of course, you can implement this that way. It could be fine. But very often, you may find this configuration for the reprocessing, where since the data is copied to the master dataset, the reprocessing consists of running the streaming logic, but in a batch pipeline for the data that is invalid, and generate the correct output to this serving layer. So to compare it, pros and cons, Kappa looks simpler. There is no two data generations for the final output. There is always one pipeline, either batch for reprocessing or real-time in normal mode. It looks also a bit cheaper because there is a single layer to manage and to learn. But on the other hand, as I said, streaming data has some data quality issues, like late data that may not integrate to the processing if it's too late. Also, it's more difficult to have data exploration. That's why probably this master dataset should help you to fulfill this task. But anyway, yeah, it's not perfect neither. But from all these two words, we could design a data architecture in practice, so something that you will be likely to use in production one day. And this data architecture could look like this. So we have, of course, some offline producers for data at rest and some real-time data producers, and each of them writes data to corresponding data sink. It can be data at rest for offline, and as data in motion storage for real-time. And later on, we can but don't have to. I bet it will help in a lot of situations, but to synchronize this real-time data into this data at rest storage for batch use cases, simply because not all business use cases require streaming processing. Even it looks very appealing to have data like in an instant. Yes, it's more complex to operationalize, and as a trade-off, it may be better to use batch for some of them. And later on, we might have two completely separated data jobs, one for the batch processing, another for the stream processing, and just generally all to keep in mind after this lesson. So you can see that it's kind of a mix between Lambda and Kappa architecture. We have two layers, and you use one layer depending on the business requirements. So if the business requires low latency data, of course we will do data processing B, but if it's fine to process data hourly or daily, then data processing E can be a better solution. So that's all for this lesson, and data architectures are not the single data. So these two data architectures are not the single points to know while designing a data architecture. Another point concerns data organization, data storage, and that's something we will see later in this module, in the next lesson, in fact. See you in the next lesson, and thanks for watching.